After many digressions, we come to the topic begins the second half of chapter 12, triple integrals. Think of a region of space, maybe a sphere, an ellipsoid, maybe a quadric surface. For simplicity, you might want to just think right now of a sphere centered at the origin. Okay, that sphere or that region perhaps comes out to a point here and over to a point here, and this is not going to look like a surface of a sphere, but let's say that that region lies above this portion of the XY plane. So there's some region, maybe a distorted sphere of some kind, where we pushed in one side and molded it around like a piece of clay. And whether it actually intersects the XY plane along this curve, the region is a three-dimensional region lying above the region of the XY plane. So every point of the three-dimensional region lies above some point here. Every point of the three-dimensional region lies above some point in the XY region. So that this region is, in fact, a projection of that three-dimensional region down into the XY plane. And there's one more condition here. I'm going to be a little ambiguous at this point. Every point of the XY region has points, a point or points of the three-dimensional region above it, above being in the sense of in the z direction from. For right now, let's simplify things even a little more, and let's assume got that on the screen. Okay, let's assume a simple surface above our XY region. If we partition our XY region, let's say we partition along X, and then we have our sample point, comes out and hits somewhere here. We've got the region around our sample point, the strip in the Y direction, and we subdivide that strip. Then we're going to have a delta X region here and a series of delta Y regions here. Let's take a sample region. Let's take this region right here, which corresponds to some interval delta Y of the Y-axis and contains a sample point. Call it yj star, and our delta x with an xi star. At our sample point, xi star yj star, we can move directly upward in the z direction until we hit the surface. Dropping this simple assumption, if there's a three-dimensional region lying above the region, we can go up until we hit a boundary of the region. We might hit another boundary a little higher, another boundary a little higher. The region could be very complex in shape. But for now, let's just assume that we have a simple surface here and that the region, the volume, the three-dimensional region we're talking about starts here and ends when we get to that surface. Now, if this simple surface, if we have a simple surface, let's let z of xy represent the surface. That is, we plug in our values of x and y into a function z of xy, and we get this distance here from the xy plane up to the surface at the point xy. Then our sample point xi star yj star is going to correspond to some coordinate z of xi star yj star lying above the point, so that this point would be xi star yi star z of xi y j star. Not sure I said j correctly, but hopefully you know what I mean. Above this rectangle in the xy plane, then, we're going to have a rectangular solid that comes up to a height equal to the z of xy in both dimensions. And simply lies above this region. We could, if we wish, then make this region a little more tangible and sketch the boundaries. Okay, that isn't sketched real well, but we can live with it. Okay, well, we can partition the z-axis so that we have a typical partition here. So we could have a delta z with a sample point zk star. That would correspond to a rectangular solid region within this rectangular prism lying above this rectangle in the xy plane. This subregion is a three-dimensional region. It has a volume. We're going to call that delta V, and that's going to be simply delta X, delta Y, delta Z. And it'll have a sample point xi star, yj star, ck star. If we partition our x interval, and for every partition of the x interval, we have a horizontal strip in the xy plane, which we partition with respect to y, giving us a typical rectangular region which extends from the xy plane up to some surface, giving us ultimately a typical three-dimensional region within our three-dimensional surface.